Hey, good morning. How are you? Chapter 8, Charging and Discharging of a Capacitor. Definition. A capacitor is an electric device formed of two conductors separated by an insulator or vacuum. This is the capacitor. It's formed of two conductors A and B, separated by an insulator or vacuum. There are here a vacuum or insulator. Capacitance of a capacitor. Capacitance, it is C of a capacitor. When the capacitor is connected to a battery, the armature of capacitor carry a charge QA and QB, which are equal but in opposite sign. The charge of two capacitor have the same value but in opposite sign. QA equal minus QB. The voltage UAB between the armatures is given by QA equal C times UAB, QB equal C times UBA. Okay. Why the charge is opposite? QA equals C times UAB and QB equals C times UBA. QB equal QBA minus QBA because UAB equal minus UBA. Okay, same value but different sign. QB in coulomb C, U in volt V, with C in farad F. Ohm's law applied to a capacitor. This is a capacitor we draw in this form. UC, it's UAB. U of capacitor equal UAB. Q equal QA, positive charge. During charging, Q increase. In charging mode, the charge is increasing. That's mean I current equal plus derivative Q over derivative T. During discharging, Q decrease. Current I equal minus derivative Q over derivative T because it's decreasing. Q equal C times UC. During charging, I equal plus derivative Q over derivative T. That means equal C times derivative of voltage over derivative of T. And discharging for minus dq over dt, that means minus c derivative u over derivative t. Time constant of an RC series circuit. RC, that means in circuit we have a resistor and capacitor. Resistor and capacitor. Time constant, it's called rho. Rho is duration during which the voltage of capacitor increase from 0 to 63% of maximum value. That means when the capacitor increase from 0 to 63% of the maximum value, that means E equal UC charging. This time, this duration is called rho. Okay, and rho, it's the duration which the voltage of capacitor decrease from max to 37% of maximum value of the value. UC equal E discharging. That means the charging with discharging, it's the same, have the same formula, but in this form, from 0 to 63%, in this form from maximum value to 37%. In both cases, rho equal R times C. The R in second, the R, it is a resistance in ohm, C in farad F. electric energy started in a capacitor. The electric energy stored in a capacitor. EC equal 1 over 2 C times E square. The electric energy stored in the capacitor have the formula 1 over 2 C, it is the capacitor, times E, the voltage, square. C in farad, E in volt, EC in joule. At T, EC equal 1 over 2 C times UC square. Okay? At T, at instant T, equal 1 over 2 times Q square over C, because Q equals C times UC. Okay? The capacitor across a resistor, charging and discharging. Case of square voltage. T is the period. Case of square voltage. We have square voltage here. T is the period. We have two channel of oscillogram. In case of T, it's between in the interval 0 and period over 2, λg equal E. In case of time, the T, it's between the interval T over 2 and T, UG equals 0. Okay? In this circuit, we have a capacitor, resistance, and the generator, square generator. Okay. In channel A, UG equal UAM. Channel A, UG equal UAM. This is the first channel, and the second channel it's UBM, from B to M. In channel B, UBM equals C. UBM equals C, the voltage of the capacitor. This is a graph that explain the circuit. In channel A, we have a square voltage. Okay. In channel B, we have a voltage that increase then decrease, increase then decrease. Okay. Remark: the phenomenon of charging and discharging of a capacitor ends practically after time t equal 5 rho. After 5 rho, in this case I draw 4 rho. We have to draw one more row, and the capacitor ends. After 5 row, this is the first row, the second row, and this. After 5 row, 1, 2, okay. After 5 row, the capacitor will end. Case of direct current voltage UG equal E. When K in position 1 charging, when K in position 2 discharging. In this circuit, when K it is in position 1, we have charging. In position 2, we have discharging. Why in position 1 we have charging? Because the capacitor it is with the battery, but in position 2, the capacitor give voltage to the resistor. Okay, an oscilloscope with memory connected as shown in figure allows to visualize the evolution of UC as a function of time. The oscillogram of C, it is in C. This is the oscillogram. Allows to visualize the evolution of UC, as function of time. Thank you.